Let's talk about Pascal's triangle today. Pascal's triangle is formed according to the following rules. At its top or its zero row, we have a number 1. Further, the sides of the triangle are formed by ones. In particular, for example, the first row consists of 2 ones, and in each subsequent row, all the internal elements are the sums of 2 elements from the previous row, which are on the left and the right sides. For example, in the second row, the central element is number 2, which is equal 1 plus 1. Further, in the third row, there are ones on the sides, and the 2 numbers inside the row are 3's, which are equal to the sum of 1 plus 2. In the next row, the number 4 is the sum of 1 plus 3, and the number 6 is 3 plus 3, and so on. Pascal's triangle makes some calculations easier and have some interesting properties. Today we will consider one of them, namely that the sum of all the numbers in the nth row of Pascal's triangle is equal to 2 to the power of n. Well, really, you can see it for yourself. In the zero row, 2 to the power of 0 is 1. In the first row, the sum of 2 to the power of 1, which is equal to 2, and this is the sum of 1 plus 1. In the second row, the sum is 2 squared, which is equal to 4, and it is the sum of 1 plus 2 plus 1. And in the third row, the sum is 2 cubed, that is 8, and it equals 1 plus 3 plus 3 plus 1, and so on. And this condition is met everywhere. But the question is, why this is so? And now we will prove it. And the proof is actually very simple. We just need to consider some row in this triangle. Let's say, for example, it's filled with such numbers. And let's now consider the next row. It will be filled with such numbers according to the rule I talked about. Each internal number is the sum of 2 from the previous row, which are on the left and on the right side. Well, if you look closely, it's become clear that each next row consists all the elements from the previous row, and they are all present in 2 copies. For example, this one is present twice in the next row. This number is also present twice in the next row. For this, it is the same, and so on. What does it mean? It means that if we look at the sum of all elements in each row, then when moving from each previous row to the subsequent one, the sum will double, since each element is repeated twice in this sum in each subsequent row. Well, since in the first row the sum is 2, then when moving to each subsequent row, the sum doubles. Then the sum in each nth row will be exactly equal to 2 to the power of n. In this case, n runs through all integers from 0 to infinity. And that is the proof. That's all for today. Thank you for watching and for your donations.